Today, we're diving into a really powerful tool that's changing the game for how data gets collected from the internet. It's called Scrapling, and it's what's known as an adaptive web scraper. But before we get into the nitty-gritty, let's start with a huge fundamental question. We live in an age that's completely driven by data, right? So where does all that raw information, the stuff that powers everything from market research to the AI in your phone, where does it actually come from?
Well, the simple answer is they get it from the web. But here's the catch, the central conflict of our story. The web is this gigantic public library, but it was never really designed for machines to just come in and borrow millions of books at once. In fact, more and more, it's designed to actively fight against that.
Okay, so here's our roadmap for today. We'll start by talking about this massive ocean of data that is the web. Then, we're going to face what I'm calling the scraping gauntlet. All the reasons getting that data is so darn hard. After that, we'll meet our hero, Scrappling, and unpack its superpowers. We'll even look at some hard numbers to back it all up, before we finish by thinking about what this all means for the future of data access. So let's dive in. The web's ocean of data. You can think of it like the biggest library in all of human history. But imagine it has one giant flaw. There's no central card catalog, no index. It's just endless shelves of information. So you see, the problem has never, ever been a lack of information. There's plenty of that. The real tricky challenge is figuring out how to build a machine that can go into that library, find thousands of very specific pages, and pull out only the exact bits of knowledge you need, all in a nice, clean, organized way. And that brings us right to the scraping gauntlet. This is the series of brutal obstacles that makes trying to automatically extract data so difficult. Problem number one, the web is alive. It's always changing. A website you're trying to pull data from can update its design overnight. A developer might change the name of one tiny button, and poof, your carefully written script, which was looking for that old name, just breaks. Instantly, your data flow just stops. Then you've got problem number two. Websites are actively defending themselves. They're using really sophisticated systems. You know, those I'm not a robot checks, like Cloudflare's Turnstile, and they have one single purpose: to spot the difference between a human and a script, and to slam the door on the script. It turns into this constant cat and mouse game. And finally, there's just the massive headache of scale. Look, it's one thing to scrape a single web page. It's a completely different universe to try and build a system that can crawl hundreds of thousands or even millions of pages at the same time, without getting blocked, without losing data, and without taking weeks to finish the job. It's a huge engineering challenge. So, with websites that are constantly changing, defensive bots trying to block you at every turn, and the pure difficulty of doing this at scale, how in the world do you get through this gauntlet? Well, that's the exact question Scrapling was designed to answer. Let's meet this smarter, modern toolkit. So, at its heart, Scrapling is an adaptive web scraping framework. And that one word, adaptive, that's the key to everything. It means this tool is smart enough to handle a quick one-off request, but it's also powerful enough to manage a gigantic full-scale crawl across millions of pages. So how does it pull this off? How does it actually conquer the gauntlet? Let's break down what we're calling Scrappling's superpowers. First, to solve that problem of scale, it's a full-on crawling framework. This isn't just about being fast, it's about being smart. It can crawl lots of pages at once, and it can even use multiple different sessions to make it look like different users, which helps avoid getting spotted. But honestly, the real lifesaver here is the ability to pause and resume. Think about it. If you're scraping 1 million pages and the job fails halfway through, you don't have to start all over again. You just pick up right where you left off. Huge. Next up, and this is where that adaptive part really shines, is something called smart element tracking. This is the direct solution to that problem of websites constantly changing. Instead of just looking for a very specific, rigid address on a page, it uses these clever similarity algorithms to recognize the content you're looking for, even if the box it's in has moved or been renamed. This shows you the difference perfectly. The old way is like telling your script, hey, go find a box with the exact label main content. If the website changes that label to primary content, your script is totally lost. Scrappling's way is more like saying, go find me the box that looks like this and has this kind of text inside. It's just way more resilient. Now, to get past those anti-bot security guards, Scrapling uses what it calls advanced fetching. You can basically think of this as its toolkit of spy gadgets. It can automatically rotate through different IP addresses, so it doesn't look like one person is making thousands of requests. It can handle login sessions to get data from behind a paywall. And it can even control a full web browser, making its clicks and scrolls look almost exactly like a real human is doing it.
And here's where things get really futuristic: AI integration. Think of it like this: AI models are incredibly smart, but running them is expensive. If you feed an entire messy web page to an AI, it's like asking a genius to read a 500-page book just to find one specific sentence. It's a total waste of their time and your money. Scrappling acts like a smart assistant. It goes to the web page, finds that one crucial paragraph you need, and hands just that to the AI. This massively cuts down on processing time and cost.
So, Scrappling is clearly smart. It's resilient. But is it fast? I mean, all these cool features don't mean much if the whole process is slow, right? Well, let's take a look at the proof, because the numbers here, they don't lie. And frankly, they're pretty staggering.
Okay, let's get into the hard data. This table is from a speed test, basically seeing how fast different tools can pull text out of a web page. You can see Scrapling up against some of the most popular classic tools in the industry, like BeautifulSoup, which is down there at the bottom as BS4. And, well, you can see Scrapling is right there at the very top, taking just a little over 2 milliseconds.
But to really, really feel the difference, let's visualize it. Here's Scrapling's speed compared to that classic library, BeautifulSoup. Yeah, it's not even a contest. Scrapling is that tiny little blue bar on the left. It's almost hard to see. In fact, it's about 784 times faster. To put that in perspective, that's the difference between a task taking 1 second or taking over 13 minutes. When you're working at a large scale, that kind of performance gap completely changes what's even possible to try. And this brings us to our final thought for the day: the future of data access. Because look, a tool this powerful isn't just a cool piece of technology. It also raises some really important questions about how it should be used. The creators of Scrapling are very clear on this point. Their official disclaimer says the library is for education and research, and that users have to respect the rules of the websites they're visiting, things like the terms of service. It's a really important reminder that just because you can technically get data doesn't always mean you should. And that leaves us with one final big question to chew on. When you lower the technical barriers to accessing the world's biggest library of information this dramatically, what does that unlock? What kind of brand new services, incredible insights, and maybe even new forms of AI are going to be built next, on top of this newly accessible ocean of data?